Cobots, or collaborative robots, present a completely different approach to the regular, well-known industrial robots. They go against the reputation of their predecessors, which intimidated with additional safety requirements, huge costs, long time of implementation, and steep learning curve. With constantly shrinking sources of labor, cobots strive to empower the worker with tools previously unattainable. Nowadays, we hear more and more about implementation of collaborative robots in all sorts of applications. The great success of cobots, however, does not originate back to the giants of robots manufacturing, but a new company with a vision for a more human-friendly automation. It was 2005 when Universal Robots started chasing their dream, and soon after, the giants followed in their footsteps. And that is when cobots really took off. But let us start from the very beginning, shall we? Everything started when the Occupational Safety and Health Administration had concerns with the way that ergonomic issues were handled by the manufacturing industry in the late 90s. General Motors, with the help of professors Michael Peshkin and J. Edward Colgate from Northwestern University, set out to find a solution to this problem. Colgate and Peshkin started looking for a way to improve ergonomics for human workers without introducing new risks from robots, which is when they came up with the idea that robots and people could in fact work in partnership. Later on, as the interaction between workers and robots became more apparent, they introduced the term collaborative robot or cobot, which led to filing a patent in 1997, describing cobots as an apparatus and method for direct physical interaction between a person and a general-purpose manipulator controlled by a computer. Not too long after, a research team at the University of Southern Denmark started comparing existing automation solutions to market needs, giving them an opportunity to reinvent the industrial robot. In 2005, 3 members of that research team founded Universal Robots, which led to creating the UR5, the world's first collaborative robot able to operate safely alongside people. In 2012, a bigger version of the cobot UR10 is launched globally, capable of longer reach and handling greater payload. With the success of Universal Robots, collaborative robotics is recognized as a viable new class of robots, which leads to larger robot manufacturers launching and developing cobots. As the interest with cobots grows rapidly and they start to be considered a standard, ISO publishes a specification containing guidelines on how to ensure the safety of human workers in collaborative robotics systems. Nowadays, collaborative robots are associated with robots that can be used without fencing and share workspace with humans. But that is not the only feature that makes them what they are. In fact, according to international standards, there are 4 types of collaborative features for robots, such as safety monitored stop, hand guiding, speed and separation monitoring, and power and force limiting. Let us discuss these features briefly. Safety monitored stop is used when a robot is mostly working on its own, but occasionally a human might need to enter its workspace. For example, when a heavy part has to be handled by a robot and a worker needs to do a secondary operation on it. In such a case, if a human enters a restricted area in a predetermined safety zone, the robot will stop all its movements. It is important to notice that the robot is then not shut down, but the brakes are on. These types of robots are most efficient when the human-robot interaction is limited. Otherwise, a lot of time could be wasted as the robot continuously stops for human interruptions. Hand guiding can be used for path teaching, for example in pick-and-place applications. This collaborative feature allows for quick and easy reconfiguration of a process. However, you should notice that this type of collaboration may also use regular industrial robots, but with an additional device sensing the forces that the worker is applying on the robot tool. This type of collaboration, however, only applies to the robot while it is using this feature, which means that while functioning in other modes, the robot still needs additional safeguarding. A robot may also be considered collaborative if equipped with a speed and separation monitoring system, where the environment of the robot is monitored by lasers or a vision system that tracks the position of workers. The robot will act according to the functions defined for different pre-designed safety zones. If the human is within a certain safety zone, the robot will respond with designated speeds and stop when the worker comes too close. This collaborative feature is used for operations that require frequent worker presence. Power and force limiting is the feature that most people associate with cobots. It allows the robot to work alongside humans without any additional safety devices. The robot can feel abnormal forces in its path and come to a stop when an overload in terms of force is registered. These robots' physical design is focused to be as harmless as possible, which means rounded parts, no exposed motors, or loose wires. All of this allows for direct collaboration with the worker for a variety of tasks. In conclusion, the field of collaborative robots is vast and rapidly changing, while constant pressure on automation of manufacturing processes is pushing the industry into creating ecosystems consisting of both humans and robots, where cobots provide a healthy solution to relieving workers of tiring, repetitive, or mundane operations. This change in the industry may be the necessary step on the way to creating nearly risk-free working environments. So far, universal robots hold around 50% of market revenues, while the rest is divided between the prominent industrial robot manufacturers. And so, as the interest with collaborative robots rises, so does their market value. According to global market analyses, annual revenues of collaborative robots are forecast to reach $7.6 billion in 2027, accounting for 29% of the entire industrial robot market.